All right, hello everyone. Welcome to the very first Asteroid Hunters Research News podcast. We're going to take a go at this and see how things go here, guys. But we're basically putting together a podcast for you guys to be able to look at every week or two, and we're covering all the research that we're doing. As many of you know, we are teamed up with the Worldwide Variable Star Hunters and Mike Aitke and the team there. We also have Sam. Sam, again, your last name, I'm so sorry. What's your last name again, Sam?
Deen, D-E-E-N.
D-E-N. Sam Deen with us, who's also our resident asteroid expert and really specializes in orbits and recovering lost objects and lost NEOs out there. And we're grateful to have him on here on the stream with us today. But today we have Mike Aitke with us out of Texas there, Mike. Can you hear us there, Mike? You with us?
How's it going, guys?
All right, man.
Glad to be here.
Welcome to the stream. So yeah, we're basically just going to be, as we do these podcasts with you guys, we're going to just be covering objects that we are basically, taking observations on, taking data on, taking measurements on. We're covering everything from asteroids to supernovas to TESS as well. As many of you know, we are involved with the TESS program through NASA. We're also involved with Assassin in supernova conformations. And then, as you guys know, the Asteroid Hunters, we do stuff for the Minor Planet Center as far as orbital data observations. And we're just here to basically talk about the things that we do every week and the things that we're looking at. So this is our very first one out of the gate, so hopefully all goes well. But the idea is, guys, what we'll do is we'll be talking about the things that we're looking at, and then basically throughout the week we do our live streams where we show us actually doing the work. So Mike has a live stream as well, and as you know, I have a live stream with Asteroid Hunters. So we will put the link in the descriptions below, so you guys can go to our Twitch channels and watch those live streams go down, so you guys can see us actually recovering and getting data from the stuff that we're out there observing. So on the list today, guys, let's just talk some asteroids. I've got a few. Basically, what we're looking at, it's kind of a tough week for us because we got a full moon out there that we're coming into, so definitely makes things a little bit more difficult. So looking at the Minor Planets website, when I go through some of the data, there's very few that are looking for orbital improvement. And so what we're going to be concentrating probably on this week is this 2003 OC3. I don't know if I'm going to be able to capture it. It's a little bit low in the as far as the RA, it's kind of right when the sun goes down. I may not be able to capture it with our position of where we're at, but this is one object that needs some orbital improvement on 2003 OC3. We also have 2020. Mike or Sam, I'm sorry, rather, contacted me yesterday about an asteroid that was needing some data on, and Sam, we can talk about that as well. This 2020 DR2 is a relatively new object. I believe, and I think was this something that was lost or picked up, or is this just a brand new object that's sitting out there?
Right now, 2020 DR2 is an asteroid discovered on February 20th and basically observed until yesterday. And what's so interesting about it is that, while it's not coming particularly close to us today or any time this year, currently, they've ran some simulations of its orbit about 100 years into the future, and there's a small but not impossible chance that it might hit us on either September 9th, 2074 or September 9th, 2081. To be clear, it's a really, really low chance. The total chance is about 1 in 59,000, so you can run the numbers on that. It's really tiny, but right now, we'd rather have a 0% chance of an asteroid apocalypse than a 1 in 59,000 chance of it. So astronomers have been trying to get some more observations of it right now. I've been working on trying to get some images of it in the past that some telescopes may have imaged it before it got discovered and just didn't bother reporting it or didn't even notice it.
Okay. Well,
what's the size of this asteroid?
It's about 500 meters to a kilometer across, which I'm too scared to do the math myself, so I'm going to translate that.
The kilometer or bigger is global killer, right?
Yeah, it's about a third to sixth of a to 0.6 miles. So
Okay. Yeah.
it's not tiny.
And looking at the object, looks like it's kind of on its way out, on its orbit, on its way out of the outer end of its orbit is what I'm looking at on this graph here that I see from the orbit view of some of the data that's been collected. When I look at there's obviously been some observations since February, all the way through. The last observation was a Stewart Observatory yesterday. And they observed it at 17.6 magnitude, and his coordinates are here. So, but looking at it, looks like it's on its way out. But yeah, it's possible. I would love to. I think that this is definitely within our range. We may try to get some actual data on this. Again, the challenge is that the moon is so tough, man, right now. So really difficult to try to gather some data. And we tend to see a slowdown in observations when the moon starts getting full. Observations, I start seeing a lot of things start to slow down during that time frame. So
Boy, do they.
Yeah. So, and then Sam, you also have you shared in the Discord yesterday a comet that you just recovered. Let's talk about that a little bit, because that's big time.
Yeah, it's a bit less high priority to go looking at things that don't have a chance of hitting us in the near future, but there's always a bit of interest when you see these old comets that got seen 10 years ago and lost and never seen again. About a month ago, I was looking around at old comets for a little project I'm working on, and I noticed that there's a comet called C2010 M1 Gibbs, because Gibbs of the Mount Lemmon survey was the discoverer.
Okay.
The thing got discovered on June 22nd in 2010 and only got observed for like a day before it didn't get observed by anyone ever again, ever. And up to about a month ago, that was all we had on the comet, just like 25 hours of observation. And that's pretty terrible for trying to estimate the orbit of something that can take thousands of years to orbit us.
Yeah, no kidding.
So last month, I managed to find some observations of it taken by the Pan-STARRS telescope from 2 and 4 days before it got discovered, which improved the orbit a little bit, not fantastically, but just a little bit, so that it didn't have a total nonsense orbit that could be anywhere all over the place. And interestingly, what turned out from this orbit was that it apparently doesn't really come that close to the sun. Its closest point to the sun is about 8 astronomical units away, which is mostly to the orbit of Saturn. So this is a pretty far out comet.
Wow, interesting.
It's actually one of the furthest comets that we know of in the solar system. It's like top 20, something along those lines. Anyway, earlier this month, just a few days ago, another observatory actually reported they found some observations of it, also from 10 years ago, that extended its observation arc from just 4 days to 18 days, which massively improved the orbit. Massive thanks to the fellows at D90 for finding that. Don't know what the observatory name is, but it's the observatory code is D90. So, doing a bit of a search based on those observations, I actually found observations of the comet from a full month before it was originally discovered, on May 18th. Mike's showing the observations right there. You can pretty clearly see the comet on the right there, between the red crosshairs. It's not, like, impossible to see. So, if Pan-STARRS had been paying attention, they probably could have found this comet a full month before it had been found, and maybe they could have even known the orbit of the comet so well that it would still be observed to this day. Either way, now we've got, from working on finding observations of a comet, a full decade after the comet was lost, now we've managed to extend the time the comet was seen for from just a single day to a month and a half. And if that doesn't speak to the power of how powerful recovery observations are, I don't know what does.
It's amazing. And you know what I love about Sam, you guys, is Sam doesn't even own a telescope. And he does all this research right from his room at home there, you know. And you can, you know, like we shared before on some of the other casts, you can go out there and download some of these images right from these telescopes and do the research right for yourself. So
yeah, absolutely.
Incredible.
All of this data is public. For instance, on a bit more of a massive scale, there were some astronomers in 2013 that discovered a new moon of Neptune called Hippocamp right now. They discovered the moon from images taken in 2004 from Hubble, I believe, that were totally publicly available. Anyone could have discovered the moon up to that point, and it took until 2013 for anyone to even notice that there was another moon orbiting Neptune.
Wow.
Just because nobody had looked through that data for 5 years.
Now, do you find it more to be like detective work? Like, you know what you need to find, but you have to go through like the dozens of databases and agencies to find that one picture or the one fits file? Like, or is it like, how do you compile all these different sources of data to like come up with your response?
Well, it's definitely not an easy kind of thing that has a central database where you can just go in and like plug in all the things and it'll give you like, here's every single image that definitely has the thing in it.
Right.
You definitely have to do a bit of detective work in looking for stuff. The very helpful Canadian Astronomical Data Center has a little program where they do a search based on asteroid names or orbital elements or something along those lines. But there's a few things that aren't in there. For instance, there's this really prolific survey in the most recent years called the Zwicky Transient Facility. They're kind of specialized in trying to find moving objects or new objects, and they've got a ton of observations that they've been so prolific with finding these pre-covery observations that they've managed to find observations before discovery of both interstellar objects discovered to date. They were the ones who found those observations before the discovery of them. And they're currently working on releasing a third data release where they should have a lot of data up to around this month or so. So there should be a huge uptick in the amount of pre-coveries I should be able to find, or anyone should be able to find, really, in the next few months.
It's incredible. Well, yeah, and you know, Sam will contact me once in a while and say, hey, how you doing? Are you able to look at this object? And we laugh because Sam never gives me anything easy, you know. He the stuff he points to me, I'm like, oh boy, okay. So Sam, I'm going to try to get 2020 DR2 if I can this week, if possible. I don't know if it'll happen just because of the moon. I think we're honestly supposed to have some rain this week, unfortunately, which is not helpful by any stretch. But we're going to take a shot at that and see if the weather clears, we can maybe grab something, you know.
Well, hey, do your best. I only give you the asteroids because I know those ones are the ones that the surveys think are too hard to find.
Yeah.
So if it's too hard for the surveys, it's definitely not going to be easy for you.
For sure. but we always love the challenge, you know. So, but that'll be on the list for this week. And great job on the comment, man. It's just exciting stuff. And you guys can go to our Discord, join the Discord, and Sam has his own little tab in there for science discussions, and he shares all the things that he has in there. So we're trying to build a community and let you guys have access to all this data as well, and let you ask the questions. I mean, look, I know for myself, I'm just hanging along for the ride because these guys are all so good in their field. You know, my son and I just can't even believe we're here. So we got to pinch ourselves every time we're doing this. So, all right, well, that's that discussion. So let's move on to TESS. What we're gonna do in this format for the podcast, guys, is we're just gonna basically do 15 to 30 minutes and just throw it up on YouTube here and let you guys see this for every week. So we're not running too long. These videos aren't too long. We've been going for almost 15 minutes now. So let's just talk TESS. So Mike, what can you share with us on the TESS front?
So Worldwide Variable Star Hunters is a highest level SG1 observatory for the follow up of TESS for TESS data and observations. So TESS is a 2-to-1 orbital period space satellite with 4 huge CCD cameras on it that look by a 24 by 24 set of sky for 30 days. So there's 4 cameras on the satellite. It takes images size of 10 by 10 megapixels of 30 minutes all the way up until 30 days. And it looks at that sky for 30 days, then moves to another set. So it's going to do the whole sky in 2 years, basically. So I did the south field already, which I can't even look at because our telescope is in the north. So, but what TESS requires as an SG1, a level 1 research observatory, is the precision of the tracking, of the precision of the filters that we use, and the parts per million accuracy that they require to see and detect the very beginning and end of the transient through the light curves. So the bigger the mirror, the more precise, more accurate, more data of the data line that you can extract and see. Um, Basically, it's like taking, like if you had a 10-inch mirror, it would be like a 800 by 600 image, or if you take a 24-inch, it would be like an HD mirror, or if you do like a 1 meter, it would be like a UHD picture. Um, you can extract more detail, out of an image in a certain square or whatnot. So um, it took about a couple months for our process to get accepted and file all the paperwork and all the NDAs and everything like that. But we've been really awesome track record. We've doing some really exciting firsthand, first scene transients we've been doing, and so good that the people, other agencies and universities are looking us up to publish us in papers. So we're doing, we're killing it, as they say, and especially for the issues that we've dealt with and the maintenance and the weather and the storms, and it's a fighting battle, but we're definitely getting it done. And we have our latest observation is taking a lot of special eyes at JPL NASA to possibly get a confirmation.
Yeah, how much can we share? Because we've had some success here, and we've done some stuff here already, which has been exciting.
Obviously, the light curves and all the data itself is all proprietary. We can't share that. But we can kind of talk about like the past public observations, like 700D, the first TESS Earth-like size planet. But it's tough, like ground-based telescopes. It's nearly impossible to find a Earth-size planet in transit. We can find hot gas-sized Jupiter planets all day long, but anything like smaller, like Earth-size, we don't have the aperture. You can have a 10-meter scope on the ground, and it would still have trouble seeing that kind of size.
So, do we have any upcoming targets that we're able to share that you're going to be maybe trying to get over the next week or two?
We will show them on the next episode.
Okay, the next episode. So, okay. Well, again, guys, you can check out Mike's stream as well, and I'll put the link description below. But this is a big endeavor for us that we're involved in, and we've been fortunate enough to be able to be part of it as well. And a few weeks ago, Mike was allowing us to control the telescope while we were taking observations, and we had some success. So it's just an incredible endeavor. And but we have our setup here, and then Mike has his 24-inch plane wave, which is in Abu Dhabi on the other side of the planet, basically. So we've got access to other scopes around the world. So we try to collect data via other telescopes. We also have Econ Greg, who's in kind of the other side of the United States over here in Georgia, I believe is where Greg's at, and he does quite a bit of our supernova stuff as well, and those kind of things. So these are the things we're going to be sharing on the podcast. Some of the targets we'll be going after, but again, the big thing is we're going to share this stuff to you guys, but come check out the live streams, man. When we go live stream, you guys can actually see us do it in action, and we let those things go. We'll be on those for hours, and letting that stuff roll through. So it's a great thing to be able to watch this stuff go down as we collect some of this data as a team, So all right, guys. Well, we're about 20 minutes here. Do we have anything else we want to kind of go over? Again, this is our first one. And we just want to kind of give everybody a little bit of a heads up. This is what we're going to be doing, trying to show you guys the stuff that we are, the objects that we are collecting and data on, and it does vary from week to week. Is there anything else any one of you guys want to add as we're closing out here pretty soon?
Yeah, we want to try to be a little different with this podcast because we're doing real-time, first-hand research with our own equipment we're not going to just be talking about the news and things. We're
Yes.
making the news.
That's right.
So that's really what we're kind of do here is we're making the news, and we're making awesome discoveries every week and submitting them to official agencies. We're not just looking at this for a hobby. This is all going to JPL, Atlas, TESS, LIGO, all these different agencies, and all these different people are looking at our data and vetting it and make sure it's legit.
Yeah, for sure. And you know, Sam and I were talking about this yesterday. There's obviously a lot of hype about. I mean, I get this all the time as somebody that observes asteroids. You know, everybody's like, you know, doom and they immediately go to Armageddon, doom and gloom. That's not what we're about here. We're collecting the data and sharing that and trying to be able to get actual observations so we can see what the orbits are of these things. Right now, there's nothing to be worried about, and don't believe everything you see in the news, guys. I tell you that. So, but all right, Sam, anything else you want to add here as we close this thing out?
No, I think I've covered pretty much everything there is to be talked about this week.
Okay, sounds good. Well, we appreciate the time with you guys, and again, we'll be posting this up here on YouTube. We'll be looking to try to do this every week if we can, maybe every other week. We'll see. Just kind of depends on what the news flow is. Again, a little bit of a difficult week because of the moon, but this is just the start of many to come. So appreciate you guys for coming by, and thanks to Mike and to Sam for being part of this great team. And we look forward to seeing you guys again on the next episode. And please check out the live streams. All right, you guys take care.